In this video, we are going to do problem number 22, keep if. All right, so I already have it downloaded and opened up in Racket. So we're going to breeze through problems A and B and then abstract it in problem C. All right, so let's just get started with problem A. It says design a function positives dash only that consumes a list of numbers and produces only all the positive numbers. Note that 0 is not a positive number. All right, so pause the video and try to do problem A on your own. I'm going to go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So, as always, we start off with the signature. So, positives only is the name of the function, and it's going to consume a list of numbers. So, list of numbers, and it's going to produce a list of numbers because it produces only all the positive numbers. So, S plural, right? So, there's more than one, so we got to store it in the list. All right, signature, purpose, let's just cheat a little here. Produces only the positive numbers in the given list. All right, signature, purpose, let's stub this out. So define positives only, consumes a list of numbers. So let's just call this num-lst, and then it produces a list of numbers. So let's just call it empty. All right, so that's a stub. Let's write some examples now. So positives only, and then we're given an empty list. Produce empty, right? Because there's no positive numbers in this list. Let's do another example here. Let's give it the list -5, all right? Are there any positive numbers in this list? No, right? So we got to produce empty. Let's do one where there are positive numbers, right? Let's do 0 and then 1, right? This should produce list containing 1, right? Because 1 is a positive number and 0 again is not a positive number. Let's do another test here, right? Let's do more positive numbers. Let's do something like 9 here, right? We should produce the list 1 and 9 because these two are positive numbers. And let's do one more for fun. Why not? Right? Let's stick the positive number all the way over here, right? So we should produce 819 here. All right. So that's a pretty good comprehensive set of tests. And let's just run our stub against the test here. And we get some failing tests. Looks like it's just mismatches, no syntactical errors with the test itself. So let's convert this into a template. Let's stub into a template. So it's the classic recursive structure over lists, right? We have to do something when it's empty. So numList, something when the numList is empty, and something else when the list has things in it. We take the first of the list, and then we do a recursive call onto the rest of the list here. All right, so now really pause the video. Hopefully that should be all the mental scaffolding needed to solve positives only. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. Looking at the examples here, given an empty list, produce an empty list. That sounds like that fits our base case here, all right? We also do have to produce a list. So that gives us that hint there. All right, looking at the output type, right, in these examples as well, we have to produce a list. So cons is the only way to build a list here. Cons, all right. So how do we determine if this number is positive? Well, there's a built-in primitive called positive question mark, where you give it a number and then it produces whether or not it's positive. But this produces a Boolean, right? So we run this code, we see, this example list false for this one. And we get a ton of other signature violations, right? Because it's not producing a list of numbers, it's producing a list of Booleans, right? But we don't really want this, right? It is kind of working, right? So 0, so this one right here, right? 8 is a positive number, and then 0 is not, and then this one is -5, and then we should see a true next, and we do true for the next two, right? So it indicates that we need more than just this, right? This statement, we need to sometimes include negative numbers and include positive numbers and exclude negative numbers. So some decision making is going on here. So we have to deduce that we have to use an if here, right? If the number is positive, then we do the consing right over here, right? So like so, and I'm going to stick this all into one line, right? Otherwise, right, if takes 3 parts, and this is going to be the else part, right? So if the number is positive, we cons it onto the list, right? And this, I'm going to take this out, right? We cons the number into the list, right? Otherwise, we just call this recursive call and don't include it in the output list. And this should work. So if we run this code, all 5 tests do pass. All right. So now let's move on to the next problem. Problem B, design a function negatives only that consumes a list of numbers and produces only all the negative numbers. Note that 0 is not a negative number. All right. So pause the video and try to do problem B on your own. I'm going over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So as always, we start off with the signature. So this is going to be negatives only. That's the name of the function. And then we need another set of parentheses to indicate that it's the function. It's going to consume a list of number and produces a list of number. Because the purpose statement here says it's plural, right? Produces only all the negative numbers, right? So there. And that's a good purpose statement as well. So we can cheese it a little here. And then next is the stub. Negatives only consumes a list of numbers and then produces a list of numbers. And empty is a list of numbers. All right. Signature purpose stub. Let's write some examples here. Check expect. Let's just actually copy and paste all these examples above and then just rename it to negatives only for the sake of time, right? So negatives only without a question mark, my bad. So like so. And you're good. All right, so let's alternate these tests, right? So this is going to be list -5, because -5 is a negative number, right? This also has to produce -5, the second test here. Given a list 0, -5, 1, and 9, this one also has to produce -5, and this one also has to produce -5, right? Let's actually add some more numbers, negative numbers for this example, right? So let's make this -1, right? We need a -1, and let's put this a -8 here too. So that would be in the first of the list, right? So this -8, -5, -1, like so. And let's add one here, right? -9, just for some more variety, because they're all -5s. We kind of want more variety here. All right, and let's add one positive number here, right? This is going to be +2, right? This should produce empty, because we only want the negatives, right, in the list. All right, so that's a good set of tests and a ton of mismatches, but it doesn't look like any syntactical errors that are going on here. So let's turn this into a recursive template. So as always, we do something when the list is empty, and then something else when we have things in the list. We take the first of the list, and then most likely we do a recursive call to the rest of the list. All right, so that's a good template done. So now really pause the video. Hopefully that should be all the mental scaffolding needed for negatives only. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. All right, so give it an empty list, produce an empty list. That's what our base case tells us. So that's what we'll do, like so. All right, what do we do in the case of when there are things in the list? Well, looking at the signature, we can deduce that we need to build a list. And to do that, const is the only way. All right, so how do we tell if the given number, this 2 or this -5 is negative or not? Well, we can pass it to a negative question mark, like so, right? That's a built-in type 2 racket. But, you know, if this didn't exist, you can do something like this, less than 0, right? Is this number less than 0? But since negative question mark does exist, we'll just use that instead, all right? So we run this code, it's not going to work out just yet, right? It's the same situation with positive right? We get true here for this number because it is negative, and then false for this 0 because it's not negative, and then -5 is negative, so that's true, true for -1 as well, and then 9, of course, is positive, so that's false, right? So we're getting there, but what we need to do is deduce that, hey, sometimes we include numbers, sometimes we don't. Kind of indicates we need an if here, right? And if has, of course, 3 parts. Gonna hit I to indent here. And it's not reindenting, but it's fine, right? We just want these placeholders. So if the number is negative, right, then we want to do the consing of it into the list. I'm gonna hit Control I to reindent this time. And we want to cons the number on the list. So don't unwrap that negative there and just make this a one-liner. Because it's nicer to see if in 3 parts, right? 1, 2, 3, all right? So this is what happens when it is negative. We add it onto the list and we do a recursive call, right? And process the rest of the list. Otherwise, we just call this recursive call again without doing the consing. So don't add it to the list. And that is negatives only done. So we run it. All 11 tests do pass. All right. So now let's move on to the next problem. Problem C. It says abstract positives only and negatives only into a keep if function that will consume a function and then a list. All right. So you're going to have to design a keep if function. So let me just write that boilerplate here. All right. That consumes 2 arguments and does something. All right. So try to abstract positives only and negatives only into a more keep if general abstract function with the same structure and stuff, right? So try to do that on your own. I'm gonna go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So looking at these 2 functions, negatives only and positives only, they share the same general structure, right? They test whether this thing satisfies some criteria and it includes it in the list and or not included in the list, right? Same with negatives only, right? The name difference is not that big, right? What we're trying to see here is that we can abstract this negative question mark and positive question mark into a function parameter, right? We can say that someone has to pass that in, all right? So let's just copy either of these, right? Both have the same general structure, so we can abstract it away, right? Abstract away the differences, and let's just rename this keep if. All right, it's going to consume a function and then a list. So we need a function here, and that is going to replace this main essential difference here, right? Instead of passing negative question mark and positive question mark, we're going to say someone has to pass that in and substitute it, and we'll do the substitution. All right, likewise, we also have to name the recursion here. All right, and that is pretty much it for keep if. So now let's actually test this abstraction with these negatives and positives only function. All right, let's re-implement keep if in terms of it. That's the next problem, but let's write some tests to verify that's actually the same first. So check expect. So it's calling keep if with positive and then let's grab that list. Right, let's grab this entire thing actually, like so. Gonna paste this here. Is this the same? Are these 2 the same, right? It's calling positives only with this list the same as calling keep if, passing in the positive question mark function and the list, right? Will these 2 produce the exact same thing? If we run it, we see that they should, but the problem is this, let's see, line 69. So this differs from that. So let's see what the issue here is. Oh, so I didn't do the renaming properly. There's another renaming here, right? Negatives only. So it should have done this recursive call. That was kind of hard to spot, but that's good. Oh, and we get another error here. So let's see, keep if expects 2 arguments, but only found 1. So, oh yeah, whoops. That's your first argument. And we get another error. Okay. Keep if expects 2 arguments, but only found 1 is probably this here. All right, so that was something that we had to fix up, but nonetheless, same general idea. These 2 are the same, right? So yeah, let's do the same for negative 2, right? So we're gonna do another check expect here. And we're gonna grab this call to negatives only. Given this list, right? Is it the same as calling positives, keep if with the negative question mark function and then the list itself, right? Do these 2 produce the same thing? And you're welcome to write more tests, but for the sake of time, right, this is good enough. And we see that those 2 are the same functions. So that is test done for keep if. All right, so now let's move on to problem D. So use the abstracted function keep if in problem C, so this function that we just did here, to re-implement positives only and negatives only This is a good thing that we did the test because this was a little wonky, right? This was calling negatives and we forgot to put the functions as the arguments here, right? It's a 2 argument function. We evolved it from the copying and pasting this function. All right, so try to pause the video and try to do problem D on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So we verified that these 2 are the same functions. So wherever we see positives only, we can just replace it with this call, right? So something like this. So we can replace this entire because we factored it out and abstracted it into the keepIf function. And we pass in this concrete, we replace this concrete list with this abstract parameter. Likewise, we can do the same with negatives only, right? So we verified that they're the same. So we're going to copy and paste it in, right? It's the same as calling keepIf, passing the negative question mark function, and then passing this negative list like so. Run everything, and all 13 tests still pass. So that is problem D. Done. All right. And again, the reason I had you write these two functions is, of course, that when you write functions, you recognize you're writing them a second time, and that can lead to the aha moment for abstraction. All right. So now let's actually write the signature for keepIf before we move on to problem E. All right. So it's going to be keepIf consumes a function for the first argument that we know has to produce a Boolean because it's used in this if here, right? So it has to produce a Boolean, right? What does it consume? Well, it consumes a number, right? In this case, like so. All right. So this can be square braces or parentheses. You just have to be consistent. And generally, I like to make these parentheses for function calls, right? And then lists and stuff, I make them square braces, right? So this is the first argument, the function here. The second argument is a number list. So let's just write the type for that, list of numbers. And then it produces a list of number. All right. And that is the signature done. Looks like I got an error here, mismatching parentheses. Now we are good. So I run it, it's still fine. Okay. So now let's actually start problem E, right? So problem E is optional. For more practice, copy and paste keepIf function from problem C. So this is problem C, and try to re-implement 15.0 problems with keepIf. All right. So if you go to the website and you download the keepIf solution files, or maybe you've done them in the past and you can use your own solution files, I recommend you open them up. So open recent, open keepIf solutions, keepIf solutions 15.0, right? That's what we want to do. Right, we're gonna have to change the language level because it's gonna yell at us. Right, so this first option, #lang -isl plus. All right, and we're gonna copy this in, copy the keepIf that we did. All right, and we can paste it here. All right. All right, so let's do one of these. All right, so try to re-implement only evens using the keepIf abstraction. All right, I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. All right, so we can recognize that, hey, these two again share the same structure. It's this even question mark that replaces this function here. So let's just try yeeting this whole thing out and just writing keep-if and then evens question mark, even question mark, and then the num list, right? And if we run this, all 4 tests still pass, and it's still the same code, right? Same functionality, but different ways of expressing it, right? It's much more compact, right? So I recommend you submit your assignments two-handed and check your score. And that is about it for this one, and I will catch you in the next one.